What if all that is known about the universe today is limited by our own mathematical construction? What if we allow the universe to choose its own point of view rather than impose our point of view on it? What new predictions could be made? What would happen to our knowledge of space, of time, and matter? Would we find that Newtonian physics and quantum mechanics are connected? Would we find that electromagnetic waves could change the density of matter itself? Would we be able to predict quantum numbers in atoms or redshifts in the cosmos? Before he died in 2014, Ferris Williams left our world with 2 books and a number of papers describing a new mathematical construct that may answer all of these questions and many more. His model yields more predictions about the universe than any other, including those developed by Isaac Newton, Albert Einstein, Erwin Schrödinger, and Stephen Hawking combined. That theory is called dynamic theory. Williams left us with predictions of condensed matter, quantum physics, electromagnetism, gravitation, dark matter, and the arrow of time itself. Although his predictions are radical and based on thermodynamics, those that could be experimentally validated have been amazingly accurate. Yet, Ferris's work remains mostly unknown, or, worse yet, completely ignored by keepers of the flame. In this series, we will explore the dynamic theory, its implications to what we think we know, and the scientific community that continues to turn a blind eye to a new view of space, time, and matter. Hi, I'm Russ Maines, and welcome to Dynamic Theory, a new view of space, time, and matter. This video is the presentation of the fundamentals of dynamic theory and its technical approach to a description of a 5-dimensional universe. Enjoy. The 3-dimensional view of the universe described by Euclid in 300 BC yielded unimaginable command over the fields of science for well over 2,000 years. As a matter of fact, this view of the universe was the only one available to all physicists, including Isaac Newton. It was remarkable how this view enhanced our understanding of science and engineering by providing a first principles basis of physics for anyone to use. In short, it offered a remarkable predictive capability. For example, an engineer could predict the distributed loads on bridges, or an astronaut could predict the location of a spaceship given its initial location and velocity. However, certain anomalies could not be described by Newtonian physics. The concept of absolute time and the contraction of the speed of light depending on one's own movement relative to its speed posed problems for the brightest minds in the fields of physics. It wasn't until Albert Einstein described special relativity that another view of the universe became available, the concept of personal time. In special relativity, Einstein was able to show that there was a limiting velocity to all forces in the universe, namely the speed of light. Further, the speed of light was independent of everyone's personal time. Still, there was the problem with gravity. The view in the early 20th century was that if someone removed a planet from our galaxy, the entire universe would know about it instantaneously. This problem forced Einstein and others to again change their understanding of the universe by changing their mathematical construct of the universe. And while this view was difficult to grasp at first, for the first time in human history, The vast majority of theoretical physicists understood there was more than one geometry in which the universe could be described. Still, Einstein's non-Euclidean geometry makes any theoretical physicist ask the question, are there other dimensions in which gravity can finally be quantized? And the answer is yes. As of today, there are as many as 11 dimensions being explored by theoretical physicists across the globe. The problem is, most of these descriptions are actually unprovable. In other words, there is no experiment to validate that these extra dimensions are real. There's no instrument in our arsenal to measure any quantity that they predict. Therefore, the extra-dimensional space that modern physics is currently exploring is for the most part purely academic. This is what Williams describes as another log in the road. Farris asked if we should continue to chop up those logs and keep moving forward, or if we should stop, turn around, and take another path. This question was the foundation of a new view of physics that led Williams to begin exploring thermodynamics, which has never been disproven and has never been shown to have a log in the road.